So can you show this?
Uh,
So this you can try for homework, right? It's
okay.
something which you
Yes, sir.
already know in a way, but the proof here will be slightly different, maybe. Okay. So show,
Right. Yeah.
show. Okay. Once you have shown this, then you can write. Then you can say that that yeah, that this quantity is inverse of 1 minus x. Then you can write this quantity as 1 minus x inverse.
Yes. Yes, sir.
Yeah, but only after you show this according to these rules. Okay. So yeah, and remember, for showing you cannot use calculus and so on, because this is only here plus and minus, right? A plus and product
Correct.
and
Yes.
yeah.
So using like what, a ring, properties of like a ring, and
Yes, yeah,
yes.
just the rules of multiplication. You have to show that in this product, every coefficient, the coefficient of every x, every power of x is 0, except for x to the power 0.
Yes,
Right?
that will be one.
Right, exactly. That's what you have. Once you have shown this, then you can, okay, that thing is gone. Then we will know that that number Cn is very nice. It is equal to this, obviously with the inverse.
Yeah. Inverse. Yes, sir.
This is the formula which we arrive at.
Right. But again, like what is X? I mean,
X is just a symbol,
okay.
right? So what this is saying is that X is just a symbol, okay? And if you follow the rules of multiplication and addition, which is there in this ring, then the coefficients you get will be your counting, will be the
Cn.
solutions to your counting problem. Right?
Okay.
Yeah.
Yes.
Now,
Yes, sir.
whether it is useful or useless or not, that you will see later, and it also depends on what use you're trying to put it to. Okay, or whether you like it elegance or not. It's all something. Okay, yeah. So
Yes, sir.
yes, so this is an interesting thing, and these are called generating functions, right? It's the generating function, and you can read more about it. The book I like is this. I don't know. I think it's a book. Wilf. I forgot the other name, but it's called generating functionology. Generating.
Okay.
Yeah. I may not spell it correctly. Generating functionology. It's a um, what do you call with this? What do you say to this kind of name? Evocative? I don't know. Hyperbolic? Yeah. So this is the
Oh, okay.
yeah.
Right.
Yeah, you can read more about it. It will be very useful for you to try to absorb these concepts, because this will give you um, a rich source of examples when you study ring theory. Examples which are different
Right.
from
Okay.
polynomial rings and other real numbers, complex numbers. These are different kinds of rings, right? Slightly interesting. And you can also try
Yes.
this. You can do this from just what you have done so far. Show that yeah show so show that this is invertible in this, meaning that there is another thing like that which is its invertible in this, if and only if, what should it be, if and only if c naught is not equal to 0. This is a very
Okay.
nice thing. Very
So the only element that doesn't have an inverse is 0.
no. So what I'm saying is that, so look at the
Oh, C
statement.
naught. Okay.
Yes, c naught, correct. So if the constant coefficient, if the constant term is not equal to 0, then there will be an inverse.
Right. Okay.
Meaning that there will be another thing like this, which when you multiply, it becomes 1. That's very nice. Remark that doesn't happen in polynomials, right? A polynomial doesn't have an inverse in the polynomial ring. It becomes something that becomes a rational function, which is not a polynomial, right?
Yes.
So
Yes, sir.
this polynomial doesn't have an inverse in the polynomial ring, right? Its inverse, I mean, its inverse if you denote it by this or whatever, right? But this thing, it doesn't have a polynomial inverse. There's no polynomial which you can multiply to get the polynomial one. Degrees don't decrease and so on, right? So something
Yeah.
like that. But in this ring there is an inverse. You have to go to an infinite polynomial in some sense, right? In some sense.
Right.
So,
The
but
sum. Yes. Yes.
yes, that it becomes infinite, right? But this I am saying is just a small piece of this thing. That it doesn't maybe help you to find the inverse, but it's the theorem which you can prove. It's easy. It's just some calculation you have to do. Okay, and this you will be using
Yes, sir.
later to prove
Yeah.
maybe this is this some many other. So that solves your counting problem. Let's see if you have any other things.
Right.
So these small things which I am telling you, try to check them. And
Yes, sir. Yeah. Apart from this, I had another question. Olympiad.
okay,
So we have a polynomial p of x.
okay.
Oh, 1 second, sir. I'll just check. I forgot like the